Okay, we are the global warming group. We're going to talk about global warming cascade, meaning that the series of events will that leads up to the global warming, or what global warming leads to the series of events and how it affects us eventually. So we showed this is a Lego castle. In the beginning of the semester, to show that we're not really showing that human can make up the ice. I mean, it's already possible. With a little help with the liquid nitrogen, I think you can freeze up almost everything. But our focus is it possible that everything is frozen up like that in the movie? Every like every whole days of the year. So to be as a result, I mean, speak out the result first. Yes, it's possible. We have been through the ice age, a lot of things, or dinosaurs are dead previous to the ice age. But what we're concerned is that it's not possible. It's like whether it's possible or not. It's not yes or no. It's about when. When is the next ice age coming and how it will come. And we will focus on global warming as a key indicator of the upcoming ice age. So why we choose the environmental topic? We got like many kinds of biological stuff that we can choose up, but we decided to do about global warming because, as you guys all remember, last December, medicine was born. Come on, medicine was born. It's not possible, and there was other more effects. So in California, there's a serious drought. And there was a snow in Texas, right here. And then, so there's a cherry blossom blooming when there's a snow in the Texas. Cherry blossom is blooming in Washington. So something's not right. So why we decide the global warming as a key indicator is that, as you can see in this graph, this is the average temperature, and this is the end of last ice age, and the Earth itself is going through cycles of the ice age, warm temperature, ice age, warm temperature, ice age, warm temperature. And we are right now in the warm temperature area, and there was a little ice age right after the medieval warm period. So that's around after Black Plagues killing all kinds of people. After that, we have been going through a little ice age, and then we were warming. So if you look at this cycle, global warming, it's natural. We're in the warming period, so temperature should go up. But what we're concerned is that global warming caused by human is going way beyond the natural process. We are accelerating it too fast. So today we're going to show you the global warming cascade, how it formed, and then eventually how it affects to the environment. So first we're going to talk about the ocean temperature caused from the global warming. Because ocean temperature, if you guys have learned by maybe high school biology school, ocean temperature is basically the source of what decide the weather. And weather, the shift in the weather caused from the changing in the ocean temperature will affect the species in the environment, and this species will come to us. And this is one of those cascades. This is one basic line. There's more other way in the global warming. Global warming is a big issue. So, but today we're gonna focus about this, how temperature is affecting us. Also, we're trying to focus on the Pacific side. Because global warming on all Earth is too big that we can, even if I have a whole semester, I can lecture about it, and it's not really enough. So we only gonna focus on the Pacific side and what happened until now. And the reason why we decided on the Pacific side is that this Pacific side shared the Pacific Ocean with Korea. So what happens here will likely affect the Korean here. Also, there's a lot of Koreans there, different times. And California got the major impact from the El Nino in 2015, the really drought temperature, and people have to paint their grass so that their house looks green. And and also the last thing, there's a lot of population in this area, especially California. So all the effects that we're going to talk about today are the observable, so meaning we can actually look at it. And there's a lot of report from people, there's a lot of people that has been shown that, that has been reported that what we're going to show. So we're going to start with the change in ocean temperature by Joey.
So how is the ocean temperature affecting us? So basically what is happening is that, as said, the Pacific Ocean is becoming warmer. And in this graph, you can see here, this is California right here, and right here is the Pacific Ocean. As you can see, this part right here should be the normal temperature of what the Pacific Ocean should be. But indicated here, it's pretty high up, which indicates it's being very warm. And lower to the outskirts of it, it's pretty cool over here. So it's not in the normal temperature rises. And because of this, between 2013 and 2014, there was a 2.5 degrees Celsius difference. And this has affected the marine ecosystem. So many of the fishes have come and scattered off the Pacific, or other animals that you wouldn't see in the Pacific Ocean have been seen here. And an example of this would probably be like sea lions are all of a sudden showing up near California shores. And because they can't have nutrition, they aren't finding nutrition, they have to go further out over here to get what they need. And this also, like I said, causes the warm weather species to appear all of a sudden, and droughts in California to happen as well. So what is this called? So what people are calling the drought, or the thing that's happening in California, the El Nino, is called the blob. And that's when the usual warm temperatures in the ocean of the West Coast is rising. And this happened from 2013, and it leads to the ecosystem obviously being affected by this. It was seen to be a 1 to 4 degrees rise in temperature difference, and this is very abnormal. And there's 3 phases of the blob actually. The first phase has happened off the coast of Canada, Washington, Oregon, and California. And then the second phase has happened off of Alaska and the Bering Seas. And the third one, which is the smallest actually, has happened off in the smaller southern portion of California and Mexico. So what the key to this is that because of circulation, it's resulting in the upper layer of the water, and it's not having movement. So what we call the layer that divides the warm and the cool is called the thermocline, and that layer is not moving as it should be, dividing that layer. And because of the global warming that's been happening and the rise in sea temperature, that's what's preventing it. And also the wind forces and the currents that generate it are stirring up the surface of the water. So why is this happening? So what we call this whole effect is called the Pacific Decadal Oscillation. And basically what this is it happens in irregular intervals in years or decades. And this wedge could mean that the surface of the H2O in mid-latitude areas in the Pacific Ocean can flip, and the cold phase can go into the warm phase, and the cycle will continue on. That is what this is, actually. And this has happened for a period of 4 to 20 years, so it's not something that's been new. It happened since 1990. And because of this, this resulted in what Blob 3.0, which happened in Southern California and Mexico. So during the warm phase, the West Pacific becomes colder, and the part of the eastern will become warmer. And then if it's a cool phase, it will happen in the reverse. But a lot of research has also predicted that even if PVO isn't going to be there the cause, the widespread of the climate change in Southern California may be still at risk for high precipitation, and it will increase the risk of global warming there as well. So why is this happening? So basically, as I said, this is the graph because of what's been happening. This is what the PCO is. This is what the PCO is. And anomalies is basically just saying the abnormal temperature differences. And this has been calculated through that over the years of 1981 to 2014. So overall, it's been showing a vast increase in the rise. So how are they measuring this? Well, we call this the Walker circulation model, and basically what that is it's a conceptual model of what the airflow is happening in the tropics of the lower temperature atmospheres. So basically just the theoretical, the temperature differences between rising and the sinking of air circulation. So right here we have the neutral conditions, as you can see, where Australia, the northern part of Australia is, it's pretty big here, and then it's pretty decent in the United States where California is. But right here where Africa is, you can see it's pretty small. So this is what it should be, but because of El Nino right here, you're seeing the opposite effects. So you're seeing what here is in Africa, it's actually increasing and going up in the airflow, and this portion where California is a lot bigger than this one right here. So why is that? Well, Africa for this it's weaker in the air current flows compared to the Australian one. And the strongest is across what we call the Mediterranean continent. And this rising actually is coinciding with the bullseye with precipitation. And then the down arrows actually represent the dry, stable air. And so you want that to be stable as well, which is right here where the Arabian Ocean is. And because of the Earth's rotation on the axis, the wind is going to blow relentlessly from east to west, and that's going to cause what the El Nino has caused in California. And the end result basically is this sea, the Pacific Ocean is going to get warmer and the east will be cooler. And then for the oceanic conditions, you can see in the model right here, this is under normal conditions, and this is the climate change from the impact of El Nino. So right here, you can see that it's very high from what has happened right now. And then this is what it was originally. And then the climate change as well, you can see that it has risen compared to what it used to be in the way back. So with that, with global warming and ocean effects, I will pass that on to climate change.
So as Julie talked about the ocean temperature change, because of the ocean temperature change, there's a significantly different, there's a big weather change going on. And we're focusing on the west coast of the United States. So these are the place where they measure the precipitation, and this is starting from here south to north. You can see most of them are increasing except for this red box, and this increase of the precipitation eventually lead to floods. But over here, in the red box is around here. You can see the precipitation is decreasing. So this means this place is going to have really serious drought. And last year there was a really big drought in these areas, and that's already showing that the weather's changing. Okay, and this is a different map. And I'm gonna start with the average, and then if you look at the wettest and driest, especially the Seattle part over here, the precipitations are not changing, and it's in red. So if you look at here, the graph, this is red, this means dry. If you look at the blue part, it's wet. So from average to wettest to dry, if they're all the same, it means that, and it's red, they don't rain for a whole year. So the Seattle is in really bad drought right now. And then this is another graph that shows about the precipitation. And the red trend line is, if it rains, it will rain this much in the future. And if it doesn't rain, the precipitation is going to go down this much. So if you look at Seattle, the red, if it goes up to red, it will rain a lot. And it might cause floods since it's raining more than normally. But if it's going down to blue, we'll have a drought. And if you look at overall North America, they're both going up. So it means that overall precipitation is rising, so which can cause the flood. And if you look at it as a global too, it's all rising, so that the change in precipitation is caused by global warming. And this is a temperature difference. If you look, this blue trend line shows that the average is increasing 0.1 Fahrenheit ever since 1895. But a lot of people say that global warming is not really happening because if you look at here and compare to the recent years, they're about same. The temperature is about the same. However, if you look at the lower part, it's not really cold as it used to be. That's why people are saying that the temperature is rising. And this is another picture for the temperature. But I want to point out these 3 points: Seattle, Phoenix, and somewhere in Mexico. So, like the previous picture, if you look at average, and this is the hottest and this is the coldest, they don't have much temperature difference. And this, especially in California where they grow a lot of crops, fruits, vegetables, and a lot of those need really different temperature. But if there's no temperature difference, the fruit doesn't get sweet, vegetable doesn't grow if it's always hot, and some plants need cold in order to grow. So those will cause really big impact on people too, since there's not crops or foods are growing. And if we look at here for the red and blue trend line, like I said, red is like a maximum and blue is like the minimum. They are all increasing, which tells us that the temperature is actually rising. And this is a natural disaster caused by increasing precipitation or decreasing in precipitation, or the temperature. This graph is the amount of money that the US government is using respect to GDP wise. And as you can see, it's increasing. So there are more natural disasters, not in only West Coast, but in the entire US. This is a drought graph. Look at the southwest part. It's going up and down, but there's a pretty straight trend line over here. But starting at 1850, which was the start of the American Revolution, a lot of CO2 or other green gas were emitted, so which caused change in weather, and you see the drop here, slowly dropping here, but significant drop after 2000. So this shows that, and this is about how grounds are wet. So you can see the dryness goes down really dramatically, and this shows that the droughts are getting more serious and it's expanding. And this picture is at 2010. Can you press next one? Animation behind Wait, there's a pause. So this part is already brown, and this animation goes up to 2090. This part, this little brownish part becomes totally brown, which means it's really dry. And even up to here, starting from Florida up to Seattle, this whole part, including Mexico, is going to become brown, dark brown, which is really dry by 2090. Sorry about the animation. And this is one about the flood. They don't have specific standard for the flood, so you can't really say, oh, this is a flood and this is not a flood, so they don't have specific count, but they measure it's over here, it's 3, but there's 4 dots, but in Seattle, this here, there's 3 points. And if you see here, the red bar over here, the spike increase here, this is the south part of the California where the precipitation is keep on increasing. So there's a common flood going on there. And then you see if you look at here, there's more, it's a nuanced flooding. There's more common over here if you go close to 2010 compared to 1920s and 1900s. So, and if you look at here, the pink and yellow are growing too. So all of these graphs tells us that the number of floodings are increasing. And so the temperature rise, precipitation change, dry, and flood. This eventually the environment change, and this causes species to change.
So let me talk about how the weather impacts the species, and there's a lot of cause for species to affect it. So one of the things is a habitat shift, which is that their living space has been, because of due to the increase in temperature, their elevation latitude has been shifted, so they have to move away. And this little cool looking gray box here is one example for that. So it used to be in California as a wildlife, but it's no longer in California. That was due to global warming. Now they are shifted up to Nevada or somewhere around there. So you can't see this cool looking gray wolf in California anymore. And so another thing is that habitat destruction. These are caused by like drought. If there's wildfire, there's no wet moisture to calm it down, so it will kind of destroy everything. And there's also invasive species, meaning that this is like some half artificial reason and a native reason. If there's an invasive species comes in, the environment itself has some kind of defense mechanism to hold them off. But due to the change in weather, the defense system has broken down, and their environment is more suitable to invasive species. So it comes in, killing all the native species and extinct some. And there's what we call endemic species, is something like koala or kangaroo, meaning that there's only one kind of species in one area. So like koala, you can only see in like Australia. So if things change and their habitat change, they can't move around because there's where it's only relief, and they're gonna die off, basically. And they have more of a talk about the species extinction, because species research takes a lot of years. Go out to field, measuring how many species are there, how they're doing. So not really a significant recent, I guess, research has been a lot in California. But extinction itself, within 500 years, has shown that this black light is a threshold, meaning that if something passes over there, it's gone. And last 500 years, 22 species, or 22% of the whole mammalian species, gone. And it's gone, they're gone, and they're gone as well. And this white number here are possible numbers that has been gone as well. So extinction is really happening, and it is serious. And one of the things that extinction of one species is burning a group without reading it. So there's a lot of information, there's a lot of possibility that you can do with this animal, but you're killing it off. Next. So one of the defense systems that nature environment has is food web. You all learned it in bio class or high school bio, meaning that this is not a single chain. They supply them, they supply them, they supply them, and this comes to human, all kinds of spreads. So there's only just not a single layer way of that happening. So if one thing disappears, there's some other substitution that could happening, but if things getting a lot of this web, it will start to collapse. And today, I am going to show like 2 examples in the West Coast. And this cute little wolverine here is called Vancouver Island wolverine. Last seen in 1992. So it's gone. So it's the main cause is their habitat is a high elevation snowy area in Canada, up in Canada. So they like cold, but due to the global warming, increase of temperature, and the habitat destruction caused by human and weather, they lost their place to live. And other wolverine, so they are not the only kinds of wolverine. Other wolverine takes over their places, so they're gone. Next one example is this cute little rabbit here, called pygmy rabbit. I like this green part in their ears. Last in 2007, pretty recent. And there's some saying that there's some gone in wildlife and trying to make them alive in the zoo, but they're gone. So there was in Washington State, as we talked about, Washington State supposed to have a lot of precipitation. Now they're having a lot more drought. So their habitat is disrupted. And in the case of wildfires, as I said before, it kind of takes out their habitat, and it causes fragmentation, meaning that if there's a huge niche, so their habitat, and there's a wildfire, and chops them off into like several pieces. So if you guys do the math, the inner area where they're supposed to live had drastically reduced, and their surface area where they're being attacked by the predator or other sources are increased. So they're gone. So these are the two species that has been directly affected by the temperature. But we still have the food web. I mean, there's other animals and there's other like crops they're eating and trying to survive with it. But if we start taking things out, eventually it will come to us. And for our conclusion is that global warming cascade, we only showed not even a fragment, a tiny little dust. And even tiny little dust, it affects the environment. Even though it has the buffer, or even though it has defensive system, it starts affecting us. And last year, the more bigger level, as a weather level, affected us directly from El Nino or warm weather. And eventually, it will positive feedback cycle, meaning that get worse, and it will come to massive change. And once it goes through the threshold that the Earth can hold up, and here comes the ice age or other massive destruction. You can say it's going to be an ice age like this, but it could be other sources. So those animation we saw in the Frozen, well, yes, we are not going to experience it, but our children, our grandchildren, we can guarantee.